dear learners of our regular MBA and Commonwealth Executive MBA program. You are most welcome to this discussion on differentiation, maxima and minima. And you know this is the topic of your business mathematics and quantitative technique courses. For better understanding of this topic, at first you should have clear idea about any curve or line and the slope of that line or curve. You know, any curve or line represents the relationship between two variables. For example, you can see on the screen, supply curve represents the relationship between price and quantity of supply. When the price is increasing, the quantity of supply is also increasing, and the relationship is expressed by the supply function, where supply is a function of price, that is S is equal to 6P square. Similarly, the demand curve represents the relationship between price and quantity of demand. When the price is increasing, the quantity of demand is decreasing, and the relationship is expressed by the demand function, where demand is a function of price. In both the cases, price is the independent variable and supply and demand are the dependent variables. Now, you can ask the question, what will be the rate of change in supply or demand for change in price? This rate of change can be explained by slope. So, in simple words, we can say that slope is the rate of change in dependent variable with respect to the change in independent variables. Mathematical technique of differentiation can be used to explain this slope, but at first we will explain this slope with graphical methods. You can see on the screen that line PQ represents the relationship between two variables x and y. Even at point B, there is a small change in x and y. If we look at the microscopic view of the graph, you can see the enlarged form of point B, where the change in x and y can be observed. The change in x is x2 minus x1, which is very small and is equal to dx, and that dx is very near to 0. For change in x, there is a change in y and is equal to y2 minus y1, which is dy. Slope is the rate of change in y for change in x and is equal to dy by dx. As both dx and dy are increasing, the curve is upward and the slope is positive. However, for a small increase in x, if the change in y is opposite, that means if y is decreasing, then the curve will be downward and the slope will be negative. Now, you can see in case of a downward curve, for increase in x, y is decreasing. Therefore, for positive change in x, change in y will be negative. So, dy will be negative and the slope will be negative. In case of any straight line which is parallel to the OX axis, for any change in x, there will be no change in y. That means, dy will be 0 and the slope will be 0. So far, I have discussed about the slope of any straight line. Any straight line can be represented by any function, that is y is equal to mx plus c. So, in case of a straight line like this one, the slope at all the points on this particular curve will be equal. But what will happen if the curve is not straight? That means, in case of non-linear curve, how can we calculate the slope of that curve at different points? Now, you can see on the screen, for non-linear curve, in order to find the slope at any point, we have to draw a tangent at that point. As the tangent is a straight line, the slope of that tangent will be the slope at that point of the curve. you can see on the screen that slope of the tangent is the slope of the nonlinear curve at that point. Once you determine the slope of any nonlinear curve at any particular point, you should also know that for any nonlinear curve, slope will be different at different points. Now, again we can see on the screen. When the curve is upward, the slope is positive at point A and B. At point C, the tangent is parallel to the OX axis and the slope is 0. When the curve is downward, the slope is negative at point D and E, and at point F the slope is again 0. Now, as I said that any line or curve can be presented by any function. So, apart from the graphical method, we can calculate the slope of any line at any point by using differentiation. If for any function we calculate the differentiation for the first time, we will get the first derivative of that function, and that will indicate the slope at any particular point. In order to get the change in slope to the next point of that function, then we again differentiate the first derivative of that function, and that will give the second derivative of the function. Now, you may ask one question: in what way we can calculate the first derivative and second derivative of the function? Let y is a function of x, where a is the constant and coefficient of x and n is the power of x, and y is equal to a into x to the power n. Here, for the first derivative of function y, that means for d by dx of y, the constant coefficient a will be unchanged. The power of x will come down to be converted into another coefficient and will be multiplied with a, and the power of x will decrease by 1. This is power function rule of differentiation. Again, in order to find the second derivative, we can use the same formula. Here a n will be unchanged coefficient, the power of x, that means n minus 1, will come down to be another coefficient, and the power of x will again decrease by 1. Do you think that you understand how to calculate the first derivative and second derivative of any function? Just check few illustration for your practice. You can see on the screen. Now, in this table we have calculated first derivative and second derivative of any function. So, for y is equal to x cube, the first derivative will be 3x square and second derivative will be 6x. For y is equal to 21x square, first derivative will be 42x and second derivative will be 42, because power of x is 1 minus 1, it will be 0. So, it will be 42x, 42. And for y is equal to 135x, first derivative will be 135 and second derivative will be 0, because derivative of any constant will be 0. For y is equal to 100, first derivative will be 0, as I said earlier that first derivative of any constant will be 0, and similarly the second derivative will also be 0. So far you came to know about the power function rule of differentiation. Now, in case of any function with power, we have to use the function power rule. Now, you can see on the screen. How can you find the differentiation of a function with power, like y is equal to 5x plus 10 to the power 4? For function with power, the function power rule of differentiation will be applied, where the power will come down to be a coefficient and the power of the function will reduce by 1. Then the differentiation of the original function will be multiplied again. You observe that in case of any nonlinear curve, there are many ups and downs. Now, on the basis of that, we will focus our discussion on maxima and minima. In order to find the maxima and minima of any curve, we can see on the screen that maxima is a point where the curve stops to increase and starts to decrease from the next point. Minima is a point where the curve stops to decrease and starts to increase from the next point. Maxima does not provide the greatest value of the curve. There may be more than one maxima in the same curve, but maxima is the highest point within a range. Similarly, minima does not provide the lowest value of the curve. There may be more than one minima in the same curve, but minima is the lowest point within a range. Some of the minima might be higher than the maxima of the curve. Now, how can we identify the maxima and minima by using the concept of differentiation? In order to identify the maxima and minima by using differentiation, we should have clear idea about the properties or conditions of maxima and minima that can be explained in a graph again. You can see that when the curve is increasing, the slope at point A, B and C are positive. At point D, the curve stops to increase and then begins to decrease after point D. When the curve is downward, the slopes at points E, F, G and H are negative. Again, at point I, the curve stops to decrease and starts to increase again after point I. At point J, the slope is again positive. If we draw a tangent at point D, the tangent will be parallel to the x-axis. That means the slope will be 0 at point D. This is one point of maxima where the slope is 0 and next to that point slope is negative. If I draw a tangent at point I, the tangent will be parallel to the x-axis and that means the slope will also be 0. This is one point of minima where the slope is 0 and next to that point slope is positive at J, you can see. Just recall, what do you learn about maxima and minima? I said earlier that in order to find the slope at any point of a function or line, we use the first derivative, and in order to know the change in slope to the next point, we calculate the second derivative. On the basis of this first derivative and second derivative, we can explain the properties of maxima and minima. For maxima, we have to identify the points where slope is 0 by putting 0 for the value of the first derivative. Then we have to check whether the slope of the next point is negative. That means the value of the second derivative is negative. Similarly, for minima, we have to identify the points where slope is 0 by putting 0 for the value of the first derivative. Then we have to check whether the slope of the next point is positive. That means the value of the second derivative is positive. We will try to apply the concept of maxima and minima in business. Just for example, think of a company. That company is producing this type of mouse and they are selling this mouse for taka 135 per unit. Now, the accountant of that particular company is being confused because their profit has been decreased despite their increase in production and sales from 5,000 units to 9,000 units. So, by selling more units at the same price at taka 135, their profit has been decreased. We can analyze this case. We have analyzed the cost figures and revenue figures of the company. Now, you can see on the screen. Now, for a range of 0 to 10,000 units, the company can sell its product at taka 135 per mouse. Therefore, the revenue function is R is equal to 135x. For up to 10,000 units, the cost function is C, that is equal to x cube minus x cube plus 21x square plus 100, where R is the sales revenue in 1000 taka, C is the total cost in 1000 taka, and x is the 1000 units of production and sales. Now, you know that profit is the difference between total revenue and total cost. Now, by putting the value of total revenue and total cost, we get the profit function, which will be P is equal to x cube minus 21x square plus 135x minus 100. Now, in order to get the number of units for which the profit will be maximized or minimized, at first we have to calculate the first derivative of the profit function. We have got the profit function. Now, we will calculate the first derivative of the function. Now, we have got the profit function, and the first derivative of the profit function will be 3x square minus 42x plus 135 minus 0. For maxima and minima, the first derivative will be equal to 0. That means, dp by dx is equal to 0, or 3x square minus 42x plus 135 is equal to 0. Now, we can solve the quadratic equation to know the value of x. Here by using middle term breaking, we find that the value of x will be either x is equal to 5 or it will be 9. As x indicates the units in 1000, we can say that the slope of the profit curve will be 0 for 5000 and 9000 units. You know that in order to find the maxima and minima, we have to calculate the slope of the function for the next points to 5 and 9. And you know, in order to get the slope of the next point, we have to calculate the second derivative. And if we differentiate the first derivative again, then we will get the second derivative. By using the same rule of differentiation, we have again differentiated the first derivative and calculated the second derivative of the profit function, that is equal to d square p by dx square, and which will be 6x minus 42 plus 0. That means, it will be 6x minus 42. We can find the value of the second derivative, that is 6x minus 42, by putting the value x is equal to 5, and we will get that is minus 12. As the second derivative is negative, so we will get maxima at x is equal to 5, and by putting x is equal to 9, we will get the second derivative, that will be plus 12, as this is positive. So, we will get minima at x is equal to 9. We can now calculate the profit of the company for 5000 units and 9000 units. By putting the value of x is equal to 5 and 9 in the profit function, we can calculate this profit easily. Using the profit function for x is equal to 5, we find the value of p is 175. So, we can say that profit for 5000 units is taka 175,000, and for x is equal to 9, p will be 143. So, profit for 9000 units is taka 143,000. Maybe you are still confused. Why is the profit decrease for increased volume of production and sales? For more clarification, you can look at the profit graph. in the profit graph, you can see the ups and down of profit for different level of production and sales. Within the range of 0 to 10,000 units, profit has been increasing up to 5,000 units, where the profit becomes maximum. Then profit has been decreased up to 9,000 units, where the profit becomes minimum. Then profit has been increased again for a little. So, you can see that the company can set their target for production and sales to maximize their profit by analyzing the maxima and minima of their profit function or profit curve. The same concept can be applied in the cost function in order to minimize the total cost of production. Dear learners, through this presentation and discussion, I hope that you have got the basic idea about differentiation, maxima and minima. Now, read carefully the course materials provided to you. Actually, this particular course, Business Mathematics and Quantitative Techniques, require more practice. So, try to solve the practical problems of your book to be familiar with this particular topic. All the best to you and thank you.